All right, how's everyone doing today? Pretty good? Awesome. Well, I love this community so much that I took a train from Bratislava to Prague, a flight from Prague to Frankfurt, and another flight from Frankfurt to San Francisco, all within the span of 24 hours to hang out with you all today. So I am... Thank you so much. Yeah, it's been a wild ride, but I'm thrilled to be here and give a little deep dive into Apollo Client 2.0 and also what we have planned for the future. So without further ado, my name is Peggy Rayzis, and I am an open source engineer on the Apollo team, and also the host of our latest video series, Apollo Mission Briefing, which, if you haven't seen on YouTube, you definitely should check it out and hit subscribe. So our goal as the Apollo team is to make building applications simpler and faster with GraphQL. And I think this goal has really resonated with the community. We've seen astounding growth over the past year, resulting in over 2.5 million NPM downloads and almost 5,000 stars on GitHub for our most popular tool, Apollo Client. It is also the most widely used GraphQL client in the ecosystem today. And I think one of the reasons we've had so much success is because building your application with Apollo Client removes a ton of complexity on the front end. And really, all you have to do is just describe exactly the data that you want with GraphQL. And to use that data, you just bind the query to your component and forget about the rest. Now, I'm not trying to make a cheap shot on REST here. What I'm really referring to is all the rest of the things associated with data management that you don't have to worry about. So forget about fetching the data, transforming the response, normalizing it, caching it. Apollo Client does all of that for you. And that's what we're going to be talking about today. Another thing that I want to point out about Apollo Client is that it's not just React developers who can take advantage of all the amazing features Apollo Client has to offer. The client is actually decoupled from the Vue layer, so Angular and Vue developers can also join in on the fun. And everything I'm about to tell you for Apollo Client is the same for all three frameworks. The only difference here is really just how you bind your queries to your components. We talk a lot to our community members, and one of the common themes that we can pull out from their experiences working with Apollo Client is that it allows them to do more with way less code. And before I started working at Apollo, I was actually an engineer at Major League Soccer and wrote about our experience switching from Redux to Apollo. And offloading data management to Apollo allowed us to delete nearly all of our Redux code, which removed a ton of complexity from our application. Instead of writing countless lines of boilerplate, we just wrote queries and let Apollo take care of the rest. Not only do you have to write less data management code, you also can accomplish complicated features like pagination, optimistic UI, polling, and prefetching data with far less code than you would normally have to. Additionally, one of the best features of Apollo is that it caches your data for you. Let's break down what actually happens here. So from your UI, you send a query. Then Apollo processes that query by adding fields like type name and omitting any fields that are already in the store. Then Apollo fetches the data from your GraphQL server. And then once the data comes back, Apollo normalizes the data for you, stores it, and then pushes the result back to your UI. So what does it actually mean when I say that Apollo normalizes your data for you? So first, just picture like a query in your head. It's all nested. And we split each part of the query into its own object. And then we assign it a unique identifier. So in the example here, you can see we have like entry 1 and comment 1. And this identifier is used as a pointer between child nodes and its parent. So you can kind of see comment 1 under entry 1 in the example there. So then we store each object in a flattened data structure, and before we send the data back to the client, we then piece together the shape of the query. And okay, this sounds like a lot of work. Why do we do this? The reason why is because multiple queries can sometimes share the same data. So in this example, if we add a comment to entry 1, we want all the other queries who also use entry 1 to update reactively. So maybe we're pulling the top query or the feed query. Either way, we want all references to entry 1 to be updated with the new comment count. So if we all have these great features and our developers are really happy working with Apollo Client, why did we decide to release a 2.0 version? My coworker James did a really excellent job explaining all the motivations to you yesterday, so I'm not going to go into too much detail. But one of the main reasons is because we're looking to the future of GraphQL. We needed a more modular architecture to support things like streaming data and resolving from sources beyond a GraphQL server. We're really proud of how we were able to achieve that with Apollo Client 2.0, while building a smaller, faster client with minimal breaking changes. So let's dive into the internals of the client even further. So first, we have our cache. And in 2.0, you can actually swap out the default in-memory cache with a custom one if you want. The new in-memory cache, which is our default, is also not dependent on Redux anymore. So this will allow you to plug in a cache with a different state management library, for example, MobX, if you really want to. And we also have our new network stack. So our new interface for customizing the network stack is Apollo Link. And it's a super powerful way to hook into the request cycle at any point to process or retrieve your data. It's also powered by observables instead of promises, so you're no longer tied to returning a single value. And then wrapping that all together on the top level itself, you have Apollo Client, which is just a thin orchestration layer between the network stack and the cache. In fact, we already have an alternative cache you can choose from. It's called Hermes, and it's built by Ian McLeod and the amazingly talented team at Convoy. Since Convoy's payloads were very large and nested, they were experiencing slow reads and writes due to Apollo's normalization process that we talked about earlier. They opted to build a graph-based cache instead that used references instead of an identity map, so they didn't have to reconstruct the shape of the result each time they fetched it, which resulted in a significant improvement for cache reads. Now, I think this story is really cool. It speaks to the power of the modular architecture of Apollo Client 2.0 and also the strength of our community. If you have an idea, you really can build it, and I think we'll see a lot more of these custom caches for things like local storage in the weeks to come. So let's circle back to our network stack, Apollo Link. And I am super excited for Link because I really think it's going to revolutionize how we use GraphQL to retrieve and process data in our applications. You can kind of think of links like React components for your data because you can compose them and chain them together. They make it really easy to customize the control flow in your application because you can hook into the request cycle at any point. So let's take a look at what this looks like. Here we're using an HTTP link to retrieve our data. We're also chaining on a retry link, which will retry the request on an interval if it happens to fail. To chain them together, you use the from method on the Apollo link class, which takes an array of links that then concatenates it together. So now let's look at a more complex example. Here we're using Apollo link.split, which takes a function and then branches the control flow depending on the result. So here's a pretty common use case. Here we're looking to see if our GraphQL operation is a subscription. So if it is, we're using the WebSocket link to send the request over sockets. And if it's a query or mutation, we're then sending the request over HTTP using our basic HTTP link. So links can either be terminating, which means they retrieve data. So that's things like our HTTP link and our WebSocket link that we saw earlier. Or non-terminating, that means they process data. So that's anything like error handling, middleware, or retrying requests. And the one thing to note is that your terminating link always has to be the last link in your chain since it's responsible for fulfilling some kind of result. It's really easy to create your own link just by passing a request function into the Apollo link constructor. The function takes the GraphQL operation and a forward method and returns an observable. To continue the next link in the chain, you have to then call forward on the operation. I also want to point out that all links share the same context. You can also set context from within one of your components. So it's a really great communication strategy from components to your network stack, and then also among links in your network stack, since they all have access to that same context. So as you can see, links are really powerful. And since they allow you to hook into the request cycle at any point, you can start to get really creative with how you're retrieving and what you're doing with your data. So the next section of this talk is actually my favorite part, and it's going to feature some really experimental stuff that is possible because of links. And I think James kind of already gave you a teaser of this yesterday, but we're going to dive a little deeper. So who's ready to get weird? So remember we had the diagram earlier where data was being loaded from a GraphQL server. Well, what if we could switch that data out with, anything else? Since Apollo links hook into the request cycle at any point, as long as the data that's coming back is JSON or an object, you should be able to query your source with GraphQL and get back whatever you want. So this opens up the door to a really interesting use case. So what if you could query local data in your application? Things like network status, things like routing, things that you already use Redux or MobX for, and then store it in Apollo Client. This way, you get the same caching benefits, you get the ease of querying, and all the awesome features that we talked about earlier that already come built into Apollo Client without having to set up a second store or maintain it yourself. It turns out that GraphQL is a perfect fit for expressing what's happening with our application state. So let's look at an example with network status, and we're going to be using this example throughout the next couple of slides. It's a pretty common thing you're going to have to do in your application to determine whether the user's device is online or offline. And to update this, we can use a mutation. To use this information in our components, we can then write a query to read from the store. And when that network status updates, we want all the components who query that data to then reactively update. So not a lot of people know this, but it turns out you can already query and store local data in Apollo just by directly accessing the cache. So here in this example, we're using the network query from the previous slide to update Apollo Client when the network status changes. So another component, which you can see in the top left, that's that GitHunt is offline component, is able to query the information from the store and display it, which receives automatic updates when the network status changes. So let's break down what we just saw in code. So to perform the initial write, you will need to use the write query method that you can access from the client. And to use this method, we then pass in our query and then the data that we want to write to the store. And you only have to call this method once for the initial write. To update the data in the store, we call update query, which you get from the data prop exposed by React Apollo. So what you do here, you just pass in a function that returns the data that you want to update the store with. And this implementation is okay, but it's a little bit clunky. We have two higher order components here, and we're expressing our updates in terms of a query instead of a mutation, which seems more intuitive and natural. So ideally, we want to eliminate these barriers and use mutations as a more intuitive way to update the store. It's our priority to make sure your experience managing local state in Apollo is as easy as possible. We want it to be as natural as describing your state changes with GraphQL and letting Apollo Client take care of the rest. No more action creators or thousands of lines of boilerplate, just queries and mutations. So that's why we're announcing Apollo Link State. I am over the moon excited about this one. It will use a client directive to specify the fields that should be retrieved from the client. And you will have the ability to specify custom resolvers to determine how data will be read and written to the cache. And it's coming really soon. So let's take a look at what this might look like. So setting up Apollo Link State in your application will only require a couple of lines of code. And all you have to do is pass in a resolver map to the link and then connect the link to your chain. So if you've worked with GraphQL tools before on the server, this will look really familiar to you. And I recommend splitting these resolver maps up by feature, similar to how you would in the Redux duck pattern. So here's an example of what your resolver map will look like. Your resolver functions have the same parameters as resolvers on the server. So your root object, any arguments, and the context. But the key difference here is that the cache is automatically added to the context for you. And to read and write data, you'll just manipulate that cache directly. We also want to have some sort of default resolver, so you don't have to specify one each time you want to read a property with the same name as the field. In order to tell Apollo client to retrieve the data using your resolver map, you will need to annotate client-side only fields with the client directive, which is what you see here on update network status in red. And then from there, you just connect your component as usual and let Apollo client take care of the rest. So speaking of REST, if we can query local data in Apollo by using a directive, what about querying REST data? As long as the REST endpoint you're hitting returns JSON, we should be able to query it using GraphQL. And that's why we plan on releasing Apollo Link REST. So yeah, whenever I see the name of this one, I feel like it's something straight out of Horse.js. I mean, I promise we're not trolling you here. It's a REST directive, and it'll allow you to query REST data with GraphQL and then store the results in Apollo client. The API looks pretty similar to Apollo Link state. You'll have a REST link, and then you'll pass in a map of endpoints. You'll be able to specify an endpoint if you'd like using the context, or you can just fall back on the default endpoint. And to query REST data, you'll just annotate the field with the REST directive. So you're probably sitting there wondering why I haven't really mentioned schemas or type checking, and that's because we're still working that piece of it all out. So some suggestions, maybe we'll have some sort of type directive that is able to match types, or maybe we'll move type checking to build time, kind of like how Flow and TypeScript are both build time type checkers that get stripped out at runtime. I don't know, we're still working on it. But anyway, I think this is going to be huge. It's really great for front-end developers who don't control their back-end, or for people who just want to experiment with Apollo client who aren't quite ready yet to build out an entire GraphQL server. So now that Apollo Link allows us to request data from anywhere, we can use Apollo client to manage all of our application's data. And we can use directives to tell the client how we want our data. No more action creators, no more reducers, or maintaining a separate store. Whether it's REST data, local data, or data from a GraphQL server, Apollo client is truly a universal data solution. And with these new links, you'll even be able to combine multiple data sources in one query. Since directives don't change the shape of your data, they just determine how you get it. So it's really easy to combine them all into one like you see here. All right, so that was like a ton of information for 15 minutes, but I hope it got you really excited about Apollo Client 2.0 and all the creative ways you can use it in your application. So let's quickly recap. Apollo Client will enable you to accomplish a lot more with less code. The new modular architecture is super flexible and extensible, so you can tailor your network cache, your network stack, and your cache to the needs of your application. And to top it all off, you'll also be able to use Apollo Client to query and store any kind of data. You're no longer limited to just a GraphQL server. So another thing that's really cool, whether you're a React, an Angular, or a Vue developer, you'll be able to benefit from the new architecture of Apollo Client. So let's go out and build some cool stuff together. Thank you.